Okay, adding and subtracting fractions and rational functions. So the only difference with the rational function is that's going to be when you have the variable in the bottom. So like these two at the bottom, those are, actually it's just this one on the bottom left. This is the only one that's rational. Oh, you can't see my touches on this. Huh, okay, well, that's not helpful. Anyway, this bottom left one is the one that's rational. The other ones are just, they're really just fractions, but um, a lot of the same type of stuff that we're doing. So what you need to remember is that when you add and subtract fractions, they need to have common denominators. So you need to multiply here. And so to get the same denominator, you can use 20. So what I'll do is I'll multiply this one. Oh, okay. This is not my usual setup, but I'm making it work. So I'm going to multiply this one by, okay, I'm going to multiply it by 1 because that doesn't change anything. But what I'm really going to do is I'm going to multiply it by 1 over 1, which is the same thing. But what I'm really going to do is I'm going to multiply it by 5 over 5, because that's the same thing as 1. Over here, I'm going to do the same thing. I'm going to multiply this one by 1 as well. Instead of 5 over 5, I'm going to use 2 over 2, because this is the same thing as multiplying by 1. It doesn't change it. So you're still doing the same operations. So this one at the top, it becomes 2 times 3 is 6. And then 2 times 10 is 20, plus 5 times 1 is 5. 5 times 4 is 20. So from there, you just add straight across. 6 plus 5 is 11, and then 20 plus 20 equals, oh, wait, yeah, at the bottom, you don't change it. So yeah, that's how this works. Like if you have a pizza and you break it up into 20 slices, this is not going to be a good picture. So like you have this many slices of the pizza, and then you add this many more slices of the pizza. You don't add the denominators. It's just what I'm trying to show you here. You just add the quantity of those two slices. So that's the answer. So that's for the addition. Yeah, that's the addition. When you do subtraction, you start off the same way. So here's some numbers that aren't as easy. So let's do this one. So again, the way you get these to have the same denominator is you multiply by 1. So in this case, 7 and 10, I think this has to be, if you can't think of anything that they have the same, that they're multiples of, you just use the other number. So in this case, I use 10 over 10, right? Because 10 over 10 is the same thing as 1. Over here, I use 7 over 7. This will always work. On the previous one, it was a little bit easier to use a smaller number, but in this one, you cannot do that. So 7 times 9 is 63. So 63 over 70 minus 30 over 70. So you just do 63 minus 30 is 33 divided by 70. Does that reduce? 33 over 70. That does not reduce. So that's your answer. So your first 5 questions on the assignment are like these two. You find the common denominator, and then you solve it. Okay, the next two, let me split this up. Oh, what did I do? There we go. Okay, so now we need a common denominator here. It's the same process as the previous ones. Now we're just dealing with variables. So you're going to multiply both of these by 1. All right, over here, let's do 5 over 5, because 5 over 5 is 1. Over here, let's do x and x, because x divided by x is 1. So we're really not changing anything. 5 times 4 is 20. 5 times x is 5x. The whole point of this is to get a 5x at the bottom here. you'll notice these reduce, but like it's not what we're trying to do. If you reduce this, they're not going to be the same denominator. The whole point was to make them the same denominator. So your answer here, 20 plus 20, okay, here we go. 20 plus 2x is 20 plus 2x. And then 5x is at the bottom. So that's your answer. This can also be written this way. This can also be written as, man, I'm having some trouble with this. Here we go. This can also be written as 20 over 5x plus 2 over 2x over 5x, which would reduce to 4 over x plus 2 over 5. But for the sake of what we're doing today, I'm just going to have you stop here and type in that answer. So just note, this is the, just note, if you're solving it, this is the same thing. Same thing. But you don't have to worry about that. Just stop right there. Okay, last one. When you get towards the end, you might have some that are longer like this. You just do the same thing. Divide, oh man. Multiply both sides by 1. Over here, I have to use 2. And over here, I have to use 4.
Mr.
So that's
Mo,
good.
I think Sergio had a question.
Oh, yeah.
Your notes are not showing up on the OneNote. The ones for the second half.
Mm. Okay, so the process here, it's going to be 2, 3x minus 2, and then down here, 2 times 4 is 8, minus 4x plus 1 divided by 8. So it's going to be 6x minus 4 divided by 8 minus 4x plus 1. Oh, no, that's a 4 divided by 8. So your solution, let's see, 6 minus 4 is 2x. Negative 4 minus 4 is negative 8. And then divided by 8, which actually simplifies, I don't know if I put the simplification in there. So these can all be divided by 2, x minus 4 over 4. If you get to this stage and type that in and it counts it wrong, or if it counts it, I don't know, if that's technically also correct, it's just not simplified, but hopefully I counted for that when I made these questions. Well,